Okay, this is a review on page 23 in your class notes. Yesterday we did a review of 12.2, and today we're going to continue reviewing. This is mainly about permutations and combinations and counting. I didn't really do any probability type questions. So I'd like to do these 3 pages. But before we do that, this is a verse from Job, chapter 19, verse 25 and 26. I know that my Redeemer lives, and that in the end he will stand upon the earth. And after my skin has been destroyed, yet in my flesh I will see God. Okay, so there are 13 people on a softball team. How many ways can you choose 10 players to take the field? So you have players taking the field. It doesn't really say they're going to a particular position. They're just all going onto the field. So you have 13. Choose 10. Just to save time, I'm not going to type all the answers in the calculator. Just to remind you, you should know this because you've used it a lot. In this case, it would be 13 math over to PRB over, oh there you go, number 3, and then 10. Oh, okay. Oh, nice. 286. And then Jess will tell us the other answers. Standard deck of card has 52 playing cards. How many different 5-card hands are possible? This hand of playing cards is just a group of playing cards. It doesn't matter what order that you hold those 5 cards in your hand, it's the same hand. So it would be 52, choose 5, which is
2, 5, 9, 8, 9, 6, 0. 8, 9. No, 2, 5, 9, 8, 9, 6, 0. Yeah.
6, 0?
Yeah.
So 2.6 million different card hands when you're playing cards. You're eating dinner at a restaurant. The restaurant offers 6 appetizers, 12 main dishes, 6 side orders, and 8 desserts. If you order one of each of these, how many different dinners can you order? So in this case, you're just counting different possibilities. This isn't a combination or a permutation. I guess you could use combinations, but it wouldn't make much sense. You pick an appetizer, there are 6 of them. You pick a main dish, you pick a side order, and you pick a dessert. And that would be 3,456. The next question, a pizza parlor has a special 3-topping pizza. How many different special pizzas can be ordered if the parlor has 8 toppings to choose from? So if you get like pepperoni, sausage, and olive, that's the same as olive, sausage, and pepperoni. So the order of the 3 toppings doesn't matter. This is assuming that you don't get double toppings. That it's not like, oh, I want pepperoni, pepperoni, and pepperoni for my 3 toppings. So you're not doing that. So you would have 8, choose 3, which is 56. Find the number of possible committees of 4 people that could be chosen from a class of 30 students. A key word here is committee. A committee is a group. The order doesn't matter. So you would use combination. So you'd have 30, choose 4, which is
7,400.
That's a 5. How many different 3-digit numbers can you make using letters 1 through 5? Numbers can be repeated. So 3-digit number, 1, 2, 3. Anytime you see that you have replacement means that you will not use permutations and you will not use combinations. Both of those are dependent events. So if you have replacement, you're not going to use permutate, you're not going to use the C combination. So you have 3 places, numbers 1 through 5. So for each one you have 5 options. So that would be 125. Different 3-digit numbers. How many different 7-digit telephone numbers can be formed if the first digit cannot be 0 or 1? So you have 7-digit. You can reuse numbers for telephone number. So this is another replacement case. So you're not going to use combinations or permutations. You have 7 digits. And the first cannot be 0 or 1. So how many options do we have for the first?
10.
But it's
8.
10 options, but it can't be 0 or 1, so it's 8. And after that, you have 10 for everything else. 1, 2, 3, 4, 5, 6. So you have 6 zeros. 1, 2, 3, 4, 5, 6. So you have 8 million options. How many different 5-digit zip codes are there if the digit 0 through 9 can be used? And this is another example of replacement. These are independent events. So you're not going to use combination or permutation.
Guess.
So that would be 10 to the 5th, which is 100,000 options. How many ways can you arrange the letters Jordan, Jordan, to create 6-letter words? And words are in quotes. Words means they don't have to make sense. But you have 6 positions. You don't have any repeating letters here, so it would just be 6 options for the first, and then 5, 4, 3, 2, 1, which is the same as 6 factorial, which is the same as 6 permutate 6, which equals what? 720. So that's the first page. Next page. How many ways can you arrange the letters Illinois to create 8-letter words? A key word here is arrange. Anytime you see arrange, it means use a permutation. NPR, permutation. Or you could, sometimes permutations you could do it a different approach. So you could do 8 slots that you're filling 8 slots. But this would be 8 permutate 8 letters. But you have to divide out repeating letters. So you have to divide out the 3 I's that repeat. So 3 factorial. Or this is for the I. And then you have to divide out the 2 L's. This could also be typed as 8 factorial divided by 3 factorial, 2 factorial, which is 8 factorial, go over to 4, divided by 3 factorial is 3 times 2, 6, times 2 factorial is 2. And make sure you use a parenthesis right here when you're doing questions like that. So 3360. Words. A committee, that's a key word right there, committee. Committee means use and CR combination. A committee is to be formed with 5 girls, 5 boys, 8 girls to choose from, 12 boys. How many different combinations can be formed? Or how many different committees can be formed? So there are 8 girls. You're choosing 5 of them. The order doesn't matter. It's a committee. It's just a group of 5 girls. It doesn't matter how those 5 girls are selected. It's the same 5 girls. Times 12 boys, choosing 5. And that equals let's see, you're buying a new car. Congratulations. There are 7 different colors to choose from, 10 different types of optional equipment you can buy. You can choose 1 color for your car. That's probably a good idea. You don't want your car having 7 colors on it. And you can afford only 2 of the optional equipment. That's like getting nice rims or a spoiler or the race car package or something like that. How many combinations are there for your car? So you have to pick a color. So color options, you have 7. You can think of it as 7, choose 1 is 7. And then you pick the 2 equipment. The problem with 2 equipment, though, is the order doesn't matter. If you pick a spoiler and a nice rims and a spoiler is the same 2. So you'd actually have to do 10, choose 2. So you can think of it as 7, choose 1 times 10, choose 2. 7, choose 1 is 7 times 10, choose 2 is 315. An amusement park has 20 different rides. You want to ride at least 15 of them. How many different combinations of rides can you go on? So at least 15 means 15, 16, 17, all the way to 20. So we have to do this several times, 5 or 6 times. So we have 20 rides, we're choosing 15. Plus, this is an or question. At least means you're going to be adding all these options. Or 20, choose 16, plus 20, choose 17, plus all the way to 20, choose 20. Now, a fast way to do this, I guess, actually, because I don't have to do that all. You could go into your y equals menu, and you could do 20 under math over to choose. X is our variable. And then when you go to your table, you set your table to start at, 15? Starting at 15, counting by 1, delta table is what you count by. So when you go to second graph, you would have, here's 15, 20 choose 15, plus 20 choose 16, plus 20 choose 17, plus that, plus that, plus that. So you could add those numbers, and then you would get the answer. What? 21,000?
660.
There you go. Thank you. So you have a restaurant serves omelets. Omelet is an egg dish. Order with these ingredients. You have 6 vegetable type of ingredients. 1, 2, 3, 4, 5, 6. You have 4 meat ingredients. Suppose you want exactly 2 vegetable and 1 meat in your omelet. How many different omelets can you order? So you have 2 vegetarians, so you pick 6, choose 2. This is a combination because it's green pepper, red pepper is the same as red pepper, green pepper. It's the same omelet. So you have 6, choose 2 times, and you have 4 meat ingredients, so it's 4, choose 1. And you would get, so there are 60 omelets that you could order with that. Suppose you can afford at most 3 ingredients in your omelet. How many different types of omelets can you order? Notice it says ingredients. Ingredients would be 10 ingredients, vegetable and meat. So 10 ingredients. At most 3 means 3, 2, 1, or 0. 0 is a really bad omelet. You don't have anything in it. It's like not even an omelet. It's just like scrambled eggs that aren't scrambled. So you would have 10 choose 0 plus 10 choose 3, 10 choose 1 plus 10 choose 2 plus 10 choose 3. And that would be the number of omelets you have. 176 omelets. Determine whether each situation involves a permutation or combination. Use proper notation. Find the number of possibilities. Some people on the quiz didn't actually answer it. They just put permutation or combination. I want you to actually answer it. So why don't you try to do these next 5. So number 22, be careful number 22, you have a winner. First place, second place, third place. Or first runner-up, second runner-up, third runner-up. I know it's kind of strange. You usually just have 3, like gold, silver, bronze. But this has gold, silver, bronze, iron awards or something. So it's a permutation. The order matters. Order matters in a race, right? The first 2 people who finish, the first and then the second, it would be different if you switched them. The first place person would get really angry if you said, oh, it doesn't really matter who first and second. The order doesn't matter. No, the order matters. So you have 10 people and it permutate 4, which equals 5,040. An arrangement of the letters. A key word here is arrangement. Arrangement means that the order matters. You're arranging them in a particular order. Arrangement of letters in the word algebra. So there are 7 letters, and you're arranging all 7 of them, and you have 2 A's that you have to divide out. You can also write it like this: 7 factorial over 2 factorial, which is 2520. Selecting 9 books to check out from a library from a reading list of 12 books. This would be a combination, 9 books. Doesn't matter the order that you pick out these particular 9. That would be a combination. Choosing 2 CDs to buy from 10 that are on sale. That's also a combination. How many ways can 5 members of the 100-member United States Senate be chosen to be put on a committee? Committee is a key word again. So it would be 100, choose 5, not permutate 5, choose 5.
75,087,500.
So there are 75 million possible committees. That's a lot. There's even more than I thought. 20 extra committees. On the last 2 questions, I'd like to review the binomial theorem. The binomial theorem, there's 2 main formulas in this chapter. One is from yesterday's lesson, margin of error is 2 times the square root of p times 1 minus p over n. So you should know that formula. There's 1 question on the test related to this, maybe 2 questions. The other one's the binomial theorem. There are a few questions related to the binomial theorem. Binomial theorem is when you identify the number of trials, the number of successes, the probability of success, probability of failure, and it's n choose r, p raised to the r, 1 minus p raised to the difference of r and n minus r. So you don't actually have to write it. I won't ask that you write it in these terms. You should know well enough to use it, though, on questions such as this one. This might be familiar from a homework question, but to give you a general idea, there's 5 apartments. The manager has a 1/4 chance of picking the right key to an apartment. Still not really sure why she doesn't label her keys better, why she has to guess randomly. But N would be 5 apartments. The R you always get from the question. So the question is the probability that she never gets the right key out of 5 tries. So 5 tries, never would be 0. And then P would be 1/4 getting it right. And 1 minus P is 3/4. So to set up the binomial theorem, we would have 5 choose 0, 1/4 to the 0, 3/4 to the 5th. When you type that in your calculator, you would have 5 choose 0 is 1, 1/4 to 0 is 1, and then 3/4 to the 5th is 23.7% chance that she is completely wrong one day. No more than 2 times correct. No more than 2 times, that means no more than 2. 2 is the most. So that would be probability of 0 plus probability of 1, oops, not 10, plus probability of 2. Get rid of that, 0. So you have to do this binomial theorem we did in 22, you have to do it 3 times. So you have 5 choose 0, 1/4 to the 0, 3/4 to the 5th, plus 5 choose 1, 1/4 to the 1, 3/4 to the 4th, plus 5 choose 2, 1/4 to the 2, 3/4 to the 3rd. So the answer would be 5 choose 0, 24%, plus 40% is 64% so far, plus another 26 would be 90%. 90%. So she's not very good. She only is successful 1/4 of the time. So if she picked 5 keys, she's probably only get most common she's going to get is, the most common is she's going to get 1 out of 5, which is closest to her success rate, 1 out of 4. But you add those 3. Or you could do it by hand, not with the way that I did it. Last question, we have each child of a particular pair of parents has probability of 0.25 of having blood type O. So there are 4 different types of blood type. So you have O, AB, A, and B. 4 different types of blood types. Suppose that parents have 5 children, find the probability that exactly 3 have blood type O. So n is 5 kids. Your success is 3. Probability of having O type blood is 0.25. And 1 minus that is 0.75. So you have 5 choose 3. 0.25 to 3. 0.75 to 2. And the answer is 8.8%. Then the last question we have, should parents be surprised if more than 3 of their children have type O blood? So more than 3, so if here's 3, more than 3 would be 4 and 5 if they had 4 or 5 kids. So we'll do probability of 4 plus probability of 5. So this would be 5 choose 4. Quarter to the 4, 3/4 to the 1, plus 5 choose 0, or sorry, 5 choose 5. Quarter to the 5th, 3/4 to the 0. When you add those, if I remember correctly, you get 1.5%. So should the parents be surprised if they got 4 or 5 kids that had blood type O? You would say yes, they would be surprised. Yes, because 1.5% is unlikely that they would actually have. It's possible, but it's really unlikely. 1.5% is really low that they would have that many blood type O kids. Thank you for watching this video.